This module covers graphing piecewise functions. So a piecewise function is a function or graph that's made up of two or more equations. And each of those equations is going to have its own domain. And so when you're graphing those, you're going to graph each piece separately, and it's not going to be the entire graph. Each piece is going to only be graphed in its assigned domain. And so when you're graphing those, you're going to have endpoints, and they may be open or they may be closed. Some points will be included and some points won't. So if it's included, you're going to use a closed circle. If it's not included, it's going to be an open circle. And we're going to use the domain restrictions to help us figure out what points we want to use, help us make a table. And so those domain restrictions that we're given are going to be our guide to graph these. So let's look at some examples. So our first example, we want to graph this piecewise function, and then we're going to label the domain and the range. So I'm going to start out by organizing my information, okay? And I'm going to just look at, see if we can organize it in a table, okay? I've got two graphs here, two functions here, okay? Two different equations. So my first equation I've got, I'm going to put on the left side. And again, you don't have to make a table. I just sometimes find that it's easier to organize your information. So I've got x plus 3, and that is going to only be true, right? That's only true if x is less than 1. So that means no values bigger than 1 are going to be valid for this graph. So it's kind of like if I graphed this, okay, so I'm going to show you what this means. If I were to graph this, okay, and I say, okay, well, here's the entire graph. But here, this right here, this is x equals 1. Well, the values on this side are bigger than 1, but the values on this side are smaller than 1. So it would be like if I said, okay, well, I don't want any of those, right? I don't want any of those. And it's less than, so I can't include it. It would be like that. Now I need to figure out where I got to put that on the graph, okay? So I'm going to use my table to just kind of organize myself here. So I think it's always easiest to start with the value they give you. Well, I know it needs to start at 1, so I need to figure out where is that at 1. So I want to find the y value. I know the x is 1. I need to find the y value. So basically, we're going to plug in 1. So I'm going to come in here and I'm going to figure out, okay, well, if I plug in 1, I'm going to say 1 plus 3, and that's going to give me 4. So what that tells me is that I have a point at 1, 4 on my graph. Now that point, it says x less than 1, not equal to 1, just less than 1. So just like I did here, that needs to have an open circle, okay? So at 1, 4, 1, 4, I would have an open circle. Now I need values that are less than 1, so I need to find some more, okay? Find some more. So I'm going to find another one. Well, I want to pick a value that's less than 1. Okay, well, 0 is less than 1. So let's see what happens when I plug in 0. 0 plus 3 gives me 3. Okay, well, that's 0, 3. There's another ordered pair. Okay, well, that's an okay point. So I can actually put a point there, 0, 3. Okay, because now I'm just getting these points that would be on my line, right? The only one that's not included is the one at 1. All right, let's get another point. One more. So another point that would be less than 1, maybe I'll choose -1. -1 plus 3. Okay, well, that's going to give me 2. So that means that the point -1, 2 would also be there. Again, that's one of these just points on my graph. So -1, 2 would also be there. And I could keep picking points all day long as they're on this side of -1. And it would continue going. So what we just did was we graphed the first piece of this piecewise function. And now we need to do the same thing to the second piece of this piecewise function. So this is telling me that I have the equation 5, when x is greater than or equal to 1. Okay, well, if I look at when x is 1, right, I don't have anything to plug in here. There's no x, it's just 5. Okay, remember 5 is the y. So if x is 1, that means that y is 5. And since this is greater than or equal to, that means that that would have been a closed dot as opposed to the 1, 4 that was an open dot. Okay, let's find another one. Well, I need a point that's bigger than 1. So maybe 2. Again, I don't have anything to plug into, so the y is still going to be 5. So I've got 2 and 5. Again, close. I could find another one if I wanted to. But hopefully you see what's happening here. And no matter what x value I choose, that y is going to continue to be 5. Okay? So I've got all these x's. So at x equals 1, my y value is 5 and it's closed. At x equals 2, my y value is 5. At x equals 3, it's 5. It would also be that at 4 and forever in this direction. And that is how you graph a piecewise function. Now, if we look at the domain of this graph, so the domain is going to be all of our x's. And so what we're going to do is we're going to think, okay, well, if I look at the left side of this graph, that's going to keep going forever to the left. So I'm just basically trying to figure out, did I skip any x values? Are they covered? So I've got x values all here. X's, X's, X's. I've got X's. I got X's. I got X's. Still got X's. Here, something funny happened, right? But did I skip an X value here? I didn't, because that X takes care of that open circle. So if I had to list all my X's, I would have one there. So basically, if I had this number line right here, which I do, this X number line, I could have values on every single X there was. So my domain is all real numbers. Now, just a reminder about interval notation, that would be negative infinity to positive infinity, because you will need to be able to skip back and forth between those. Okay, now let's look at the range. So range is my y values. Same idea, I'm going to start at the bottom of my graph, and that tells me it's going to keep going down forever. And if this, again, was a number line of my y's, I've got y values, I've got y values, I've got y values, but I do skip something here. Okay, I skip a value because this, if we look, this is open and there is no y value there. So there's no y value at 4. And there's also no y value between 4 and 5. Okay, so how can we write that? All right, well, if we were going to write that, we could say that this is all of the y's that are less than 4. Not equal to, just less than. but it's also y equal to 5. So if we think about that, we've got all these y's that are below 4. We don't have anything between 4 and 5, but we also have y's at 5. And remember, the range has to include every y value. Now, if we wanted to write that in interval notation, it's a little bit trickier. So remember, we start at the bottom, that's negative infinity, and we're going all the way up to 4. It's open circle, so that's a parentheses. Anytime you skip something, you got to use a U. Now, 5 is included, so that's a bracket, but it's just one number, so it's just going to start at 5 and end at 5. All right, let's do another one. Number 2. Again, I'm going to have a table. I'm going to go ahead and just make up a table. Again, table is not required. I just think it makes it a little bit easier. I also like to color code them to make it a little bit easier for myself too. So my first one, I've got 2x minus 1, and that's only when x is less than or equal to 2. So for me, that means that I'm going to start with 2. I always start with whatever number is listed in my domain restriction. So I'm going to plug in a 2. So 2 times 2 minus 1. That's going to give me 4. 4 minus 1 is 3. That means I have an ordered pair at 2, 3. And since it's less than or equal to, that's going to be a closed dot. I'm going to do it again. And I want the x's that are smaller, less than 2. So I might pick 1. So 2 times 1 minus 1, that's going to give me 2 minus 1, which is 1. So I have the ordered pair 1, 1. Again, that's going to also be closed, because that's just a point as we're going through. I'm going to pick one more, so another number smaller than 2 would be 0. And that's going to give me negative 1. So I've got 0, negative 1 as my ordered pair. Now I'm going to go and I'm going to graph these. So I've got 2, 3. I got 1, 1. 0, negative 1. Make sure when you graph them and connect your dots that you're connecting them on the right side. This isn't going to keep going in forever in both directions. We started at x equals 2 and we're going in that direction. Okay, so that's your whole graph for that piece. Now we're going to do the same thing with the next one. So we've got negative x. This is only when x is greater than 2. Means I'm going to start with 2. So negative 2. Well, that's just negative 2. So that means I've got an ordered pair at 2, negative 2. It's not or equal to, that means it's open. I need another number that's bigger than 2, so I'm going to try 3. So that means my ordered pair would be 3, negative 3. That's not my starting point, so it's going to be close since it's just a point on my graph. I'm going to do one more, and I'm going to do 4. So I get the ordered pair 4, negative 4. Again, it's just a point on my graph. And I'm going to go put those up here. So I've got 2, negative 2. Then I've got 3, negative 3. 4, negative 4. And that's going to keep going in this direction. Okay. And there's our graph. Now we just have to find our domain and range. So our domain, if we look at our domain on the left, that tells me it's going to keep going forever. So I'm looking at my x's. These are all good. I'm good, I'm good, I'm good, I'm good. Again, we got to check right here. Well, I didn't skip an X because this fills in that hole. So no X's were skipped here. Still got X's. I got X's everywhere. That means negative infinity to infinity are all real numbers. Okay, let's look at the range. So this tells me I'm going down forever. It's okay that they overlap. That doesn't matter. I'm just looking for make sure I don't skip any. So range is covered. I got Y's. I got Y's. Got Y's. Got Y's. Got Y's. But then they stop. And I don't have anything up here. So that means that for my range, I'm going from negative infinity, and I'm going all the way up to 3. And since that's a closed dot, it's going to be a bracket. Remember, this could have been all real numbers. Also could have been y is less than or equal to 3. All right, last one. Again, we're going to make us a table. Put my table above it. Some room. So this would be my first one. So negative x plus 10. And that's only going to be when x is less than 0. So again, I'm going to start with 0. Okay? And if I plug in 0, negative 0 plus 10, it's going to give me 10. So my ordered pair is 0, 10. Since it's not or equal to, it's going to be an open circle. Okay? Then I'm going to get another point. I'm going to get one that's less than 0, so negative 1. So negative 1 plus 10. Two negatives make a positive, so that's going to give me 11. My ordered pair is negative 1, 11. Remember, that's just a point on my graph now. All right, one more point. Let's try negative 2. Remember, two negatives make a positive, so that's going to give me a positive 2 plus 10. So I've got 12. My ordered pair is going to be negative 2, 12. All right, we're going to do, take that and we can graph it. So I've got 0, 10. And that's not on my graph, but that's okay. And negative 111 is also not on my graph, but that's okay. Oh, and you know what? I got so distracted by it not being on my graph, that was supposed to be open. And then we had one more over here. So this, not on my graph, but no big deal. We'll make it work. All right, now we're going to do this one. Same idea. So x, 4x minus 5. And that's only when x is greater than or equal to 0. Okay, random stuff. So, again, I'm going to start with 0. So 4 times 0 minus 5. So that's going to give me 0 minus 5, which is negative 5. So my ordered pair is going to be 0, negative 5. And that one's going to be closed since it was or equal to. I want numbers that are bigger than 0, so let's try 1. So then I get 4 minus 5, which is negative 1. So I've got 1, negative 1 as my ordered pair. And we'll try 2. So 4 times 2 is 8, and 8 minus 5 is going to leave me with 3. So 2, 3 is my ordered pair, and let's see if these fit on the graph. They do. So I've got 0, negative 5. I've got 1, negative 1, and 2, 3. Okay. And so then there's my, that was bad. There we go. Here's my graph. All right, so the only thing we have left to do now is find the domain and the range. So domain. Okay, so don't forget we had that part of our graph that didn't really fall on the dots, but that's okay. I still know it's going to keep going this way, right? It's going to keep going this way forever, even though it's not there. Okay, so you've got all these x's, all these x's, all these x's, but then right here, this is where we got to look, right? Anytime we have this jump, that's where we've got to really pay attention. So yes, there's an open circle, but there's a closed circle here. So we are good. Nothing got skipped. So everything over here is covered. Everything in the middle is covered. This is going to keep going forever. So all real numbers. Everything is there. So we've got negative infinity to positive infinity, or all real numbers. Okay, now you gotta look at the range. So our range, definitely not all real numbers because there's nothing down here. Right? Our range doesn't start until right here. And so that's 1, 2, 3, 4, -5. So at -5, I start with y values. And then I'm good. I got y's, I got y's, I got y's, I got y's. Now that's going to keep going up forever. So that keeps going up forever, which means my y's keep going up forever. So for my range, it's going to start at -5, and then it's going to go up to positive infinity. Since it's closed, it's a bracket. We could also write it as y greater than or equal to -5.